So in this paper I'm going to take a look here at the R code for Big Data New Tricks for Econometrics that was published by the Journal of Economic Perspectives in 2014 by Halvarian. If we go to the portal, we can see it's the Journal of Economic Perspectives. If we download the full PDF, we can come in here to figure 5. So we're going to examine in particular Home Mortgage Disclosure Act data tree, this ctree or conditional inference tree, and we're going to examine the extent to which people were approved or rejected for mortgage applications. When we observe the darker shade here, it denotes rejected for mortgage application. The lighter grey balance here denotes accepted. So if we follow the structure of the conditional inference tree, we can see that if somebody was approved for insurance on their mortgage and their credit score was relatively low, and the proportion of monthly payments towards the mortgage as a percentage of overall monthly income, and yet again the credit score was low in the less than or equal to 1, then we would find that the vast majority of that bucket of 1,272 applicants would be approved for their mortgage. In contrast, if the individual was not accepted, if they were denied mortgage insurance, overwhelmingly those individuals, not that many, only 48, in the sample, overwhelmingly they also would have been rejected for their mortgage application. Okay, so we'll take a look at here at the code what drives this, and again the code can be obtained. So this snippet of code that constructs the C-tree, we obtained that from the portal. We'll just go back for a moment, and if we come here to the dataset and then go to ML data, there are 4 folders, and one here relates to HMDA, and then there's different snippets of code, PDF files, but this snippet of code is what we're going to address. Okay, so let's run this code then, see what happens. We want to set up figure 5, so we start off here, we load in the data, HMDA data that's available in the ECDAT package. We also will load in party, right? And we might take a look at that party for a second. It's a package specifically used for data for decision trees, machine learning, conditional inference trees, right? Also party kit. If you have a later version of R, you may have to use party kit as well as an option, and this code will work using the party kit package. Okay, so if we come over, some definitions are provided. So if we run our data, we have it here available. If we just eyeball that data, we can see here the variables are available, the headings. If we go back out of the viewer into our script, we can see the definitions here. So DIR is the debt payment to total income, HIR is the housing expenses to income ratio, LVR is the ratio of the loan to assessed value, so it's the loan to value ratio, CCS is the consumer credit score, MCS is the mortgage credit score, the PBCR, public bad credit record, DMI, denied mortgage insurance, self means self-employed, single if the applicant is single. Urea is, again, this was data from 1989, so the Massachusetts unemployment rate in the applicant's industry. Condominium should be condominium. refers to race, so it's either black or not a race. Deny, mortgage application denied, and so on. So we can take a quick look. If we run head HDMA, then we get this output again, and just again we could look at this in terms of the Rstudio viewer. When we look here at black, we either have no or yes. Deny is no or yes. Credit history, public, PBCR also no or yes. DMI no or yes. Loan to value ratio is expressed as a decimal. HIR and DIR both expressed as decimals. Okay, now we can take a look at the overall descriptive statistics. Maybe more meaningful would be the mean of each, so we can run that, and the mean of the DIR was 0.33. So this is the amount of payment relative to the debt. The HIR is the amount of in-house expense to total income ratio, and the mean is 0.25. The loan to value ratio, the average was 0.73. Again, intuitively that might make sense. The mean value for the credit score was 2.11. I think that goes from 1 to 6, and less is better. And the mortgage credit score mean, we can run these numbers and observe. Again, it's a no or yes. The number of no's, proportion of denied mortgage. Most people actually weren't denied their mortgage. Most people. The mortgage insurance, so denied mortgage insurance. Vast majority of people obtained mortgage insurance. Okay, so that's something we might take into consideration. Also, self-employed. Let's just run this again. And again, so self-employed, most people are not self-employed, just 11%, 12% self-employed. In terms of being single, 60% must have been couples, 40% single, and then high school diploma. We don't get numbers out. Unemployment rate, the mean unemployment rate at this period in 1989 was 3.77 for those who are applying for mortgages. And then not a numerical value proportion who were black. 85% were not black, 14% who made applications for mortgages were black. And then in terms of deny, 11%, 12% were denied mortgages. Their mortgage application was denied. 88% or so were accepted for their mortgage application. Okay, so let's delve in a little bit further and construct the CRR tree. First of all, we exclude data we want to complete cases to HDMA. So when we run this all, you notice that one of the things that appears here, if you look at the HDMA, some of the results had NAs. And when we run, let's go back again, HDMA complete cases HDMA, then all excludes one of those is excluded. Let's look at that. The last one here is excluded, so we don't have NA here in the last and the final one, and we reduce one of the rows. So we started with 2,381 and we delete the row that where originally there had been NA appearing in the row. Okay, so we'll go back to building the C tree, and let's run the data. So we're running the C tree. We're saying linking deny. So we're trying to explain where we denied mortgage or not in terms of the applicant. And this full stop then comma implies we use the entire data set, and the data set that we're using is all which is we have here in the global environment. So we run that, we have all fit, and then we plot our graph. So we plot all fit, which is the object we created here, and then we can zoom in and we can see that the structure that we get mirrors what's in the paper. So if we go back to the paper, we can make the direct comparison between the two. Again, how do we understand this? Again, it's no harm to explain the intuition here. If mortgage insurance was denied, so in other words, yes, then the vast bulk here, but only 48, their mortgage was rejected. Yes, the mortgage was denied. If the mortgage insurance was accepted, if the mortgage insurance was not denied, so no, and the credit score was less than 3, so the credit score, consumer credit score, ranged from 1 to 6, and less than 3 would have been relatively benign, perhaps. And if the DIR was less than 0.4, DIR being the ratio of monthly debt payment to total monthly income, was less than 0.431, and again, if the consumer credit score was less than or equal to 1, then the vast bulk of these individuals who fell into that bucket, their mortgage application was accepted. So only a small number, yes, their mortgage was denied. If the credit score, consumer credit score, was greater than 1, and there was PBCR, so PBCR would have meant a public record, public bad credit record. If yes, that meant there could have been bankruptcy or charge-offs or collection actions. Then we can see that there's a discernible difference between those and those who didn't have that public record of bad credit. If again, the ratio of monthly debt payments to total monthly income was less than 0.4, denoting perhaps individual with tight budgets, and their mortgage credit score was less than or equal to 1, in other words, no late mortgage payments, then those individuals still stood a good chance of having their mortgage accepted, their mortgage application accepted. But if it was greater than 1, in other words, no mortgage payment history, or 1 or 2 late payments, or more than 2 late payments, this range from 1 to 4, this mortgage credit score, if greater than 1, again, it looks as if it's about 50-50. If the credit score, consumer credit score, is greater than 3, normally meaning issues around their credit history, and the public there's a public bad credit record, yes, then we can see we're close to 6% rejection. If the loan to value ratio, again, is greater than 0.95, so that's a very small amount of equity, or maybe hardly any equity, chances of being accepted are low. But if it's less than 0.95, chances seem to improve. Again, another factor here is the ratio of monthly debt payment to total monthly income. If that's a bit high, then chances of being rejected are increased. If it's low, it improves. And then this last factor here is black, which denotes ethnic group. And if the individual is black, their chances of being accepted for mortgage is lower than if they were any other race. So again, if you read the paper, there's a suggestion that this seems quite marginal, but there have many studies been completed that address this. In this instance, the C tree with these other factors suggests black is not that important.